What is up, guys? Fahir here from AwesomeTuts.com. And now that our player is moving and jumping, let us add our first enemy in the game. For that, we need to go in our project and in the sprites folder. So here is the assets folder, then go into the sprites folder, and then you have enemies. Here is where all of our enemies are. So we have the bee, so we have the beetle, bird, so on and so forth. The first one that we want is the snail. So let me just find it here. Sea, fish, snail. Here it is. So the snail, this dude right here. Let me open him. This one right here. This bad boy. Look at him. He is very bad. Waiting for, well, to snatch us. So what we need to do is select him. The sprite mode need to be set to multiple, and then go into the sprite editor and slice all of these parts. Now, click here, slice, and then slice again, and voila, here you are. So this is the first part, second, third, fourth, and fifth part. Then simply hit apply right here. So hit apply, and we are done. So we have sliced all of the parts of our snail, and now what we need to do is create the animation. So select from snail_0 up to snail_3. Select these 4 parts and drag and drop them right here. Look at the big snail. Look at, he's just gonna eat our player. Nom, 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 nom. Now, anyways, just drag and drop those 4 parts right here in the scene. Go into the animations folder. Click here, new folder. Now, depending on if you're using Mac, you're gonna click here, new folder. On Windows, I'm sure there is something similar. You can, I think, right click or something like that to create a new folder. And I'm gonna call this one Snail Animations. And hit enter. And this is the folder where I wanna save this. And this is gonna be our snail walk. So snail walk like this, and I'm gonna hit save. And bam, we have created our snail walk animation. Now, because our snail was probably on some kind of steroids and it's big as hell, we need to resize our snail before we continue to do anything else. For that, we are going to select the scale. So select the snail, and in the inspector panel, in the transform property, you have the scale. We are going to say that scale X is going to be 0.3, the scale Y is going to be 0.3. So 0.3, 0.3, and voila, here is our snail. Let me just select it here in the hierarchy and rename it to snail. I am also going to take the animation panel and put it right here and create another animation for our snail. So I'm gonna click on the drop down list here. This is not our first time creating this type of animation or creating a new animation clip. So when you select the game object in the scene and go into the animation tab, you will see here this animation. So you will see the name of the first animation or the current selected animation, the default one. Then you can click on this drop down list and click on create new clip. I'm gonna save that in Snail Animations, and this one is gonna be called Stunned. So this is gonna denote that our player or the snail is stunned, and we're gonna denote that with the number 4 or _4 animation of the snail, which is, well, this one that you see at the bottom right corner of my Unity editor. So now I'm gonna put back this animation tab, and we are done with the animations for the snail. You see here we have the snail walk, and then we have stunned. We will use this in our code, don't worry about that, but before we continue, we need to add a collider and a rigid body to our snail. So let me select the snail in the hierarchy, click under add component and filter for the box collider 2D, and hit enter to apply that box collider on our snail. Now, one thing though, that we are not gonna leave the collider like this. I am gonna resize it a little bit on the X axis, so something like this, and move it, so offset it, something like this. I think it will do, because I do not want the snail to kill the player as soon as he touches this eye or something like that. Instead, or actually, let me just take the snail like this. And the size X is gonna be 2.75. So 2.75. Yeah, let's leave it like this in the beginning. If we see that this is not good, then we will change it. And moving forward, so we left it as it is for the box collider. We are gonna filter now for rigid body 2D and apply that to our snail. So we have the rigid body 2D and we have the box collider applied on the snail. By the way, before we even try to move the snail, let's freeze the rotation on the Z-axis. We saw an example of that with our player. So when we started to move him, he just fell down like he was drunk. If you remember that, that was because we did not froze the Z rotation of the rigid body. Let's go in our project. Assets and scripts. I'm gonna right click and create a new folder and call it enemy script. So enemy scripts. Inside of this one, I'm gonna right click and create a new C# script. I'm gonna call it snail script. Let me attach it first on the snail like this, and what we are gonna do. So first open the script in mono develop. Let me just tag the class. I've explained why am I doing that, and I've also explained why am I giving here enter to give a little bit of space every time I repeat that. I hope that you don't mind. Anyways, what do we need for the variable properties of for the snail? Well, of course we need the movement speed. So we're gonna need a public float move speed, which by default I'm gonna say it's equal to 1. We set it to be public, which means it is visible in the inspector panel. So again, if I go back here, you will see that it is visible in the inspector panel right here. So the current value is 1. I can set it at 4, 5, 10, 22 million. Does not matter because it is here in the inspector and we can change it. That's why I set it to be public. We also need private rigid body because we're going to use the body to move our snail. I'm going to call it my body. We also need a private animator, which I'm going to call anim. And we also need a variable to denote if we are moving. So we need a private bool move left. Now we also need one more variable, and for that we will need to create a game object, which we will do in a second, but I'm going to call it public transform. And this variable is going to be down collision. Now, what is this? Well, remember raycasting for our player. If I go back here, remember the raycast? We're going to use that in order to move our snail. And for that, we will need the down collision that we are going to create right now. So go back in Unity Editor, select the snail, right click on it and create empty. So right click, then create empty, and here it is. This is going to be our empty game object. I'm going to call this one down or bottom collision, however you want to call it. So select it, bottom collision, and I'm going to reposition this game object. So let's say for the X, I am going to say -0, so -0.9. And for the Y axis, I'm going to say negative, so negative, come on, where's negative? -1.25. This is the position of this game object. Why is it like this? Well, because we are going to do the following. We are going to move our snail left and right. So left and right, left and right. But we are going to use this bottom collision to detect when we are off the ground. And how we are going to do that? Well, let me demonstrate that by duplicating the ground. And let me just set the scale back to 1. And I'm going to put it right here, something like this. Actually, let me just resize it a little bit. Something like this. Does not matter. The important thing is that I'm going to use the snail and place it right here on the ground. Let me see. It will fall. Yes, it will fall. And now we're going to move the snail left and right. So we're going to move it, and then you're going to see what I mean by all of this. So going back into our mono develop, what we need to do is in the update function, we are going to do the following. If move left, so if move left, we're going to move our game object to the left side. And how we're going to do that? Well, we're going to call my body velocity is going to be equal to new vector 2, like this. And we're going to pass the negative speed, so move speed. And for the y-axis, we are simply going to say my body velocity y. This is if we are moving left. Else, if we are moving right, we're going to use the same line of code, except this time it's not going to be the negative speed, but it's going to be the positive speed. And let me just remove here the negative. Again, remember, and I talked about this and I will repeat it one more time just for clarity. In Unity, this is the coordinate system. So here is y, here is x. So y here, x here. Positive side on the x is on the right. Negative side on the x is on the left. Positive side on the y is up and negative side is down. So here is negative, negative, positive, positive. So remember this. If you want to move a game object to the right, that means move it to the positive side. Use the positive value. If you wanted to move it to the left, use the negative value, because then you will move it to the, well, negative value, as I already said. Now, before we actually test this out, we do need to go here and in the awake function, so void awake, we need to get a reference to the rigid body and the animator. So we're going to say my body is going to be equal to get component rigid body 2D. Nothing new. We already did this. Rigid body is a component attached on our game object. Using get component will get us a reference to that component. Anim is going to be equal to get component. So get component, animator. And in the start function, we need to say that move left is equal to true. So move left is equal to true so that our game object starts moving to the left side. This is the initialization. So nothing new, just in the awake, get a reference to the rigid body and the animator because we need them. And move left is equal to true. Going back in Unity, select the snail and attach the bottom collision in this down collision right here. So attach it, drag and drop it, and attach it right here, just so that we don't get errors later on. And notice now, if I hit the play button and run the game, you see the snail is moving and now it fell down. Bam, what is going on? This is not what we want. We want the snail to move like this. This is how we want the snail to move. So we want it to move up to here. When it detects that it cannot go any further, it will change direction and go here. And then same thing happens here where it detects it can't go any further, change direction. So move left and right, left and right. How can we achieve that? Well, we can achieve that with a function that we are gonna create right now. So let me go back here. Right below the update, I'm gonna create a function called void check collision. This function is going to be called in the update. So right here below these if-else statements, we're going to call check collision like this. Inside of this check collision, we're going to do the following. We are going to check if physics 2D, so physics 2D dot raycast, and we are going to raycast from the down collision dot position to, or where is the direction? It's going to be vector 2 down, and the distance is going to be 0.1. But we're going to do one thing. That is, we're going to say or add here an exclamation mark. What is this exclamation mark going to do? This exclamation mark is going to make what's after it the positive. We know that when we raycast and we actually have a collision, so that ray detects a collision, it will return true. But this exclamation mark will make it the opposite. So essentially here we're testing if we don't see any, or if we don't detect collision anymore, do the following. Again, this raycast, we are going to raycast from this bottom collision, so from this position right here, so this one we are raycasting, and if we detect collision, it will return true. But if it does not detect collision, it will return false. The exclamation mark will make what's after it the opposite. If it returns false, then this will make it the opposite, which is true. So essentially here we are testing if we don't detect collision anymore, do the following. So do what's in right here. And what's going to be here? We're going to say move left is going to be equal to the opposite of move left. Again, I'm using the exclamation mark. What does this mean? Exclamation mark, again, will make what's after it the opposite. So in our case, move left will be equal to the opposite of its current value. So in the start function, move left is equal to true. When we hit this if statement, we will say move left is equal to the opposite of the current value, which is true. What is the opposite? It's false. So now move left is false, which means right here we will execute the else statement and our snail will start moving to the right side. And still we are checking collision. And again, when we don't detect that we can move, we are going to hit this if statement. And again, we are going to say move left is equal to the opposite of its value, which previously was false. So the opposite of false is now true. Let's test it out. If I go back here, Hit the play button now. Notice what's gonna happen when the snail hits right here. Notice now, bam, it starts going backwards, but you see we have a problem. What is the problem that we have here? Well, the problem is that we need to also change the direction. So going here right below our void change or collision, we are also gonna change the direction and change the movement. So here I'm gonna say void change direction like this. And what we are going to do inside of this change direction function? Well, here we are simply going to call our vector3 and we're going to get the temp scale, which is going to be equal to transform local scale. And we are going to say if move left. So if we are moving to the left and we can actually move this code. So this move left code, we can move it like this right here. So we can call it here in change direction. We can change, are we moving to the left or setting the left to the opposite of its current value? And then we are testing. If we are moving left, we need to face our game object to the left. So we're going to say temp scale.x is equal to madf absolute value of the temp scale.x. Else, if we are not moving to the left side, we're going to say temp scale.x is equal to the negative. And then we are going to pass the absolute value like this. Now, the last thing or the last step that we need to do is call our transform.local scale is equal to the temp scale. What is all of this right here? What did we do? This matf absolute or abs, this will return the absolute value. If I go here, now this snail is created, or this art of the snail is created in that way that when it faces the left side, its scale is positive. When it faces the right side, the scale is negative. You see here? Because it is drawn like that, unlike the player. So unlike our player, where he is, here is right here. So our player, when he is facing the right side, his scale is positive, but when he's facing the left side, his scale is negative. You see the difference? The difference between the scale is that it is by default looking to the left side when the scale x is positive. So if we want to make it look to the right side, the scale needs to be negative. You see right here. Now the scale is 0.3. Instead of me typing here is equal to 0.3 like this, I can simply use the absolute value as I already did. So absolute value will do what? It will make this value positive. You know, in math, if you've been in any school or if you saw a school, you know that the absolute value of any number is the positive of that number, which means even if I put here, so if I say absolute of 100, that is 100. So this value right here, this will return 100. Absolute of negative 100, it will also return 100. So the value is positive. But here, I'm using the negative in front of the absolute value, which means when we need to change it to the left, if previously it was negative, it will make it here positive because absolute values are always positive. Here, we need to say that the temp scale, or we are passing the absolute, which will return the positive number, but we say here negative in front of it, which will make it the negative of that number. Essentially, here the value will be 0.3 and here it will be negative 0.3. And then we're simply reassigning that local scale, so temp scale, back to the local scale so that our snail actually changes the direction. And now we need to call this inside of our if statement right here. So if we cannot move, or if we detect that we are not raycasting anymore, then we will change the direction. Let's test it out. If I go back, hit the play button, and wait for the snail to go here. Let us wait for it. Bam! You see, it is changing the direction now. You see, it is changing the direction. And let me just go like this. You see, the snail is now changing the direction every time it detects that we don't have collision anymore, because that collision is right here. You see where it is? As soon as it goes out, bam, it does not detect anymore, and it will change the direction of our game object. It changes the scale. He is looking to his side where he is actually going, as you see all of this right here. And he is changing the direction. Again, how we are achieving that? Well, here we are simply moving it. We are simply setting the move left to, well, if it's true, then we will move it to the left side by using negative speed. If it's false, else move it to the positive speed. This is nothing new, move it to the positive side, that is. Here we are checking for the collision in the update function. If we don't detect a raycast at this position anymore, that means that we don't have a ground to move on, which means we need to change the direction and move into the opposite side. So here we will say move left is equal to the opposite of its current value, which will make it go from false to true, false to true, false to true, true to false, so on and so forth. It will make it one time positive, other time negative, or false and true. Because, again, I said that this or exclamation mark will make what's after it the opposite. If the current value of move left is true, this right here will make it false. If the current value is false, this right here will make it true. So, then we are simply using the scale, and we are changing the scale to the positive or the negative depending on where we are moving. Now, don't be confused. Move left, we are moving to the left side, but we are changing the scale to the positive. I already explained this is how this art is drawn, so that initially or by default the snail is looking to the left side when his scale is negative, or actually positive, excuse me. So this is for the snail movement. We are still not done with the snail enemy overall, but enough for this video. Fahir here from AwesomeDudes.com. See you guys in the next one.